Alright, so I just did this entire video, recorded it and everything, and then it didn't save. So I'm going to do it all over again. It's going to be awesome. Alright, so this is for AP only. So if you're not in my AP Physics 1 class, you're watching the wrong video. Alright, that said, we talked about impulse, which, to answer an earlier question, is represented by the letter J. We learned about momentum, which is m times v. We learned that impulse is equal to the change in momentum. All good. Why do we really care about this, though, Mr. Saslow? You might ask. Well, I might say in return, it's because sometimes stuff hits other stuff. And momentum is helpful in this case. It's helpful because in a collision, which is what, stuff hitting other stuff is, momentum is conserved. This means that your total initial momentum has to be equal to your total final momentum. Just like mechanical energy. It doesn't matter where that momentum is. It could be in thing 1, in thing 2, in thing 3. It could then, later, be all in thing 3. It doesn't matter. The total amount has to be the same before the crash as after the crash. Now, there are two types of collisions that we care about. The first is an inelastic or sticky collision. This is where you have two things that collide, and then afterwards, they're one thing. Now keep in mind that velocity is a vector. It has a plus or a minus, a left or right, and up or down, which means momentum itself is also a vector. Alright, so that's cool. Want a little picture of that? Sure, of course you do. Here's thing A, it's moving. Here's thing B, it is not. Then, bam, there's a crash. Insert crash noise there. Then you got one thing, that is mass AB, moving off together. Brilliant. Alright, next. There's also elastic, or bouncy. So this is whenever you have two things hit each other, and they don't stick together afterwards. Or if they only kinda stick together. But we're going to pretend that things only either stick together perfectly or bounce perfectly. So we are only dealing with perfectly inelastic and perfectly elastic collisions. So this is when, to use my picture from before, I got thing A and thing B. Nothing's going on. Then, insert crash noise. I got thing A not moving, and thing B is moving. Craziness! Or maybe thing A is moving a little bit, and thing B is also moving a little bit. Or maybe thing A is going backwards now, and thing B is going forwards. Doesn't matter. Any of these things could be a perfectly elastic or bouncy collision. Now, what this means mathematically, well, that means that MA times VA initial plus MB times VB initial has to equal MA VA final plus MB VB final. Ooh. But hold on a second, you might say. 1, 2, 3, 4, 5, 6 variables? Mr. Saslow, I can't use this equation, because you're never going to give me 5 things, so this equation is useless. Well, you're right. I'm never going to give you 5 things about any given problem. I will, however, give you 4 things. But, Mr. Saslow, that means I'd have to solve for 2 variables at the same time. Why, yes, you will. Luckily for you, though, in an elastic collision, kinetic energy is conserved. Now, in all collisions, mechanical energy is conserved. We know that. It goes from kinetic to potential, potential to kinetic, whatever. Escapes as heat, sound, light, sparks, whatever. What I'm saying is in a perfectly bouncy, elastic collision, the kinetic energy is conserved, which means the total kinetic energy beforehand has to equal the total kinetic energy after, which means Ka initial plus Kb initial has to equal Ka final plus Kb final. Now we know, of course, that the equation for kinetic energy is 1/2 mv squared, so that means that this is going to be 1/2 mv squared plus 1/2 mv squared equals 1/2. Are you bored yet? I'm bored. Mv squared plus, almost done, 1/2 mv, oh god, squared. These are supposed to be final. All right. Ta-da! Oh, look. There's a 1/2 in each term. Oh, well, that would have saved me some time. Whatever. All right, so here we go. Which means that you now have two equations, equation 1 and equation 2. And using a system of equations, or by substitution, or by adding the equations, or whatever crazy math technique that was taught you that lets you solve for two variables at the same time, use it. Ta-da! Oh, one thing. Momentum's a vector. Which means it can be broken into x and y components. Now, why did you mention this, Mr. Salso? Well, because it turns out that when I said momentum is conserved in a crash, I lied. Momentum is not conserved. Y momentum is conserved, and x momentum is conserved, but net momentum is not necessarily conserved. Which means if you have anything moving off at some angle, you first have to break it into its x components and its y components, do all of this crazy stuff for the x direction, then do it again for the y direction, and then, at the very end, use Pythagorean theorem to solve for the net momentum, and arctangent or something like that to solve for theta. Alright, now, I've given you a bunch of interesting problems that are all accident reconstructions. What that means is I've given you police reports on traffic accidents, where you are asked, as insurance investigators or officers of the highway patrol, or someone, lots of people do this sort of stuff, using the math and science that you just learned. You have to figure out what happened. Well, what are you going to know? Well, you're going to know tire marks. You're going to know coefficients of friction. You're going to know masses of the car. And then you're going to have, whatever the witnesses tell you. And using this information, you're going to have to somehow figure out what happened in the car crash. In other words, what was their velocities right before the crash? All right. I only want you to do case files numbers 1 to 4 today. Try. If you don't finish, that's fine. And I'd like you to give me your answers on the discussion boards on FL. So make a category called Case 1. Everyone gives me their answers. Make a category called Case 2. Everyone gives me their answers. So on and so forth. Now, if you finish 4 and you want to go all the way up to 7, You can, but don't, because that's what you're doing in class tomorrow. All right, that's everything. Have a good day, and do physics. Go.